Okay, everybody, welcome back. We are going to start in with advanced shell programming for the next topic for this. Getting close to the conclusion of this weekend. So advanced shell programming, well, it's really not advanced shell programming. What I'm going to do is look at some techniques to ensure that shells and themselves and scripts, shell scripts, are employed with the correct shell. We've actually kind of seen some of this stuff already, so it's just complementary stuff that goes along with the last lecture. Setting the default shell, how to do that, and then configuring the bash login and the login scripts. I kind of mentioned where to find them, but we really didn't talk about any configuration parameters or anything for them. So also using and looking at setting the defaults for VI editor, if you're going to take that route, or nano, depending upon your editor choice, and using the test commands for programming functions, and looking at the format of a record output, and kind of a sample little application of a script, deleting records using a script, stuff like that. And a record format would be like a, sort of like a struct or something like that from a C language implementation. Setting up a quick screen clearing technique, creating a programming algorithm to solve a cursor repositioning problem. Developing and testing a program to eliminate the duplicate records, and creating a shell script to use them in the program. So how do we ensure that we have the correct shell that runs in the correct script? We've actually kind of seen this. We specify the script at the beginning, and this is one of the biggest issues in terms of troubleshooting scripts when we start writing them, is if it runs in the wrong shell, we end up in a situation where the script doesn't perform properly because one of the commands is failing. And when you're running a program, especially with C or C++ or something, even Java, the commands are pretty well known. If the program compiles or partly compiles, you know you're on the right track. Here you don't have any pre-compilation. Instead, you're relying upon the ability that your script contains the right commands, and it does if you're writing it in the right. If you're loading it into the right shell, but if it accidentally gets put into the wrong shell, you have issues. So each one of the Unix and Linux users can choose which shell they want by default to ensure the correct shell is used when you run a script. Not all shells support the same number of commands. The first line is going to basically specify, and we've sort of saw that in the previous lecture. So in terms of setting the default shell without having to worry about setting it in the script itself, the system administrator generally does this, or someone with administrative access. You might actually need root access to modify your own user account script files. So the administrator establishes the default shell for the user account, and this is going to be in a file that's called etc password, believe it or not. In there, you're going to have the default shell specified. File can only be edited by system administrators, so you'll have to have supervisor privileges or know the administrator password in order to actually access and edit that, even though you're the user. Some systems provide management software assets and setting default shells. Also, there's a lot of GUI configurations that allow you to set and edit shells and stuff like that, shell declarations. So when using bash login and logout scripts, when the bash is the default shell, the scripts run automatically upon the login and reentry. And these are the typical names. In fact, on a MacBook, I believe it's, I haven't looked at it in ages, but I believe it's bash RC that also runs in the subshell. And then we have bash profile. In fact, both of these are available on the MacBook. And these are where you're going to set the information, and the syntax for the file you're going to see by example when you open up the file and you look at it. It's just like any other ordinary script file. Administrators control, and it's usually in etc or etc profile. So if I closed my window here, new window. Here we go. I do have an etc directory, and in here, oops, I have should have. It's not gonna, let's see. Oh, I have C shell. Okay, so this is a good example. Here actually is some scripts for my C shell login. So I see I have corresponding, I didn't find the bash ones here, but there's probably, this is in alphabetical order. Here I have bash RC that I set myself actually as a login script, but here we have ones that are specific towards the C shell. And the reason why I'm showing this to you is you can see the file names are slightly different. This is actually the equivalent to this one here and this is when you open up the shell window, the script that runs automatically. So versus when you log in to the shell versus when you log out of the shell, when you open up the shell window. So it's kind of tricky trying to figure out which script do I need to change for which situation, which is essentially in my computer here, it's in my etc. directory, which is the same as the slide set. You might find it in a different directory depending upon your system. So if I do a nano, let's see. Well, actually, you know what? I'm not quite sure the name of the file it would actually be, but long story short, I can open up the script in a text editor and I can actually take a look at it and edit it. So those are the ones looking, oh, I didn't open up the profile, but it's going to be in a similar location. In fact, there's a profile out there. So the bash logout runs when the user logs out, often used to clear the screen. And here's an example here, actually. If you do more.bash_profile from the etc. directory, if your system is configured this way, you'll get more actually kind of just gives you, you know, it'll stop on each one of the pages so you can actually read the output. You'll see some of the configuration information. If you're new, I wouldn't mess with the scripts, but if you have something, and normally it ends up as a user, you normally end up with something where you have to like set something in the script for a particular command or something like that to work. So this is the script profile example. You probably could find it on your own system if you looked hard enough. Setting the defaults for using a VI editor. So to use the VI editor for code development, if you wanted to do that or configure the .exrc in your home directory, you can actually set things like default mail programs, default editors, default shells, and this is what this is referring to. So automatically set up the VI environment. You can set up the number of tab spaces to use for nesting lines of the code, display line numbers. Using a test command, you can place a test command inside of the script or execute it directly from the command line. So some uses of a test command might be to perform a relational test with integers, test strings to see if a string exists, what the string equals to, determine if a file or a directory exists and what type of file it is, or perform some sort of Boolean test on the system. In terms of performing a relational integer test with the test command, these are some of the options that are available to you. Is it equal, is it greater than, and what I'm talking about is like, the regular relational algebra test. If x is less than or equal to this and greater than that, and doing a test on it to kind of sort of see if anything needs to be done, or if something should continue or not continue. So the test command returns an exit status that indicates the results, whether it's 0 or 1, being true or false. We actually sort of saw an example of this in the last lecture I gave in terms of scripts that test, bring back test conditions instead of setting variables or something of that nature. And this is just some more information to give you of some of the different options that are available. And the example over here is using test as the name of the script. A, test, does it equal B, is it less than B, greater than B? And here in terms of performing the relational integer tests with the test command, here's another example of a little screenshot showing you a value is equal to 17 as an example. Test the value, is it equal to 17? And then echo a question mark, saying yes it does, or no it doesn't equal to 17. So coming back with 0 or 1. You can perform string tests with the test command as well. And in this particular case, the string option with the test command, so we've got test minus z, is it a string? And the word that you're using is actually test. Actually, let me just see if actually that's supported here. I'm kind of curious. Yep, it is supported. So if I set a variable and I said, test space, is it equal to 17? Well, it's going to be, well, expected an integer. Well, okay, so test 17 equal to 17. Well, it's going to come back no. I mean, it's going to come back yes, obviously. Otherwise, it would come back with 0 or something. So actually, I don't believe this is going to work, but let's see. No, it's going to come back the same. It's redirecting. I have my shell's not actually set up correctly, and I'm not running a script on it, so you get the idea. The test is a keyword to actually test the parameter itself. So test minus z, is it a string? Is it non-zero string length? So testing files with test command. To test a file itself, you'd go test minus b, the file name, and then come back with true or false. Does it exist? Is it a special block file? Is it a string file? What's inside of it? So depending upon what you're looking for and what the utility is, test comes in handy for scripts because it allows you to do some error checking. It allows you to do some condition control before the script actually fails. So you can kind of predict the output or the outcome of the script. So in terms of performing Boolean tests with the test command, here's some options as well, using the and, the ors, the logical and ors, and the negatives, the opposite. And these are the expressions that would be used. The exclamation point negates the value of the expression. Kind of the same thing in C or C++. When you use the not equals with the exclamation point equals, this is not equal. And or is pretty similar to most programming languages. In terms of using the test command, here's another one. We can go echo, what is your favorite vegetable, and then read the vegetable name in. This is kind of a way of getting input actually automatically. If it equals to broccoli, then echo out broccoli is a healthy choice. Else, print out carrots. I'll make this a little bigger so you can kind of see what I'm reading to. But this is a classic example of using test here in an if statement to see if the user input equals something. So if it does equal something in an error condition, you might say, hey, I'm sorry, you're using the wrong script, or something of that nature. In terms of formatting record output is formatted using the translate utility, or the TR. And you're going to see this in one of your assignments, which is why I'm going over it. So one of the assignments has you run TR until you're blue in the face, and then you go, oh, that's what the TR is all about. It stands for translate. So use TR to change the characters typed at the keyboard, character by character. It also works as a filter. So when you input comes from an output of another Unix command, which is what you're going to do in the assignment, take the output and change it all to lower characters or upper characters, or switch it around, reverse the string or something. You can also redirect the standard input to come from a file rather than the keyboard as well. There's some stuff with the TR TR command. TR was used to change the lowercase characters to uppercase and then replace the colon characters with spaces. And I'll zoom in a little bit here. You can kind of see the command right here, actually. This is the one that you're going to be interested in. And this will help you actually blend out with the homework assignments. So, using a grep command with a telephone number. Oops, here it goes. I'm using, here we go, grep with a telephone number with a variable, and we're piping in the TR command. We're combining the command with TR to replace this with this, essentially. And so it'll go through and replace the items in the file with the items in the variables with what it's supposed to be. So, and you'll probably go online, you'll probably see more examples actually when you're doing that assignment, because you'll have to figure out how to combine commands, how to take the output, translate it to something else. And it's a good exercise because it kind of gets you familiar with the concept of not only writing commands, but using TR and redirecting the output, and then piping, combining it, because there was a pipe symbol in that last example actually, to pipe, and I talked about piping yesterday, but to connect the two programs together essentially. And then it creates some really cool automation in Unix. So we can delete phone records. In this particular example, we're going to use sed. Sed is also one of those commands that you're going to see in the homework assignments. So it takes the contents of an input file and applies the specific actions to the file's contents. So it sends the results to the standard output. And then the -d option of sed can be used to delete the matching records from the output. And here's an example of sed. The sed command is behind the delete option here. And there's a little menu. It says delete the phone number. And so there's a sed command back there. So running the delete phone option will implement a sed command. So the record is no longer in the file, and the file is just going to be a flat file. So a lot of times, in case this is actually a good example to bring them up, a lot of times Unix people will put together these little text-based menus because users like menus, short keys and stuff. It makes it easier to run something. And they'll put the data in a file, regular old text file. And so This particular one is a corporate phone reporting menu, and we saw it in the previous slide, somebody's name, an address, a telephone number, information. You can put those in. It's actually referred to as a record in the Unix, and actually it comes from a record concept. Either records being stored in separate files or records being stored all together in one file. It's used. It's kind of a makeshift database. If you think of it that way. But databases themselves are nothing more than storage of records. It's in a table, in a database optimized. Unix, everything's a file, so it's stored in a text file that you can easily open up, manipulate, change, translate. And if you store it in a text file, it gives you the options actually to run a lot of Unix commands on that. Pipe the output, alter the text, do all sorts of things with it. And so text files are kind of a popular thing in Unix. Not to be confused with Microsoft Word, and people usually figure this out too when they first start programming and they start using Word to write source code in it, and they figure, oh, there's like formatting characters in there. It doesn't compile right. I need to use Notepad for that, or I use a text editor. So there's a big difference between formatted text and flat, plain ASCII text in terms of these utilities as well. Because if you wrote a file in Word and you used it like a text file in the same context, wrote a script, your script that was written in Word is not going to run. Even if you save it as text, it's not going to run because there's formatting characters, line returns, there's all tabs, margins, all a bunch of stuff in there that doesn't belong. And the scripts are read line by line, character by character, word by word. And you'd have to strip that out and clean it up in order to actually use it as a script. So what you're looking at now is clearing the screen. We have a clear command. I've actually used it for you. I've demonstrated it earlier. Typing clear, choose for clearing the output. But there's a faster way. So you can store the output of a clear command in a variable and then echo the contents of the variable on the screen. So you have everything stored in temp files, kind of, because it's in the history. Actually, because you could save those files as well. About 10 times faster than the actual command, since the system doesn't have to locate and execute the clear command. Instead, it just shows the echo information. So here's an example here where you say clear is equal to clear, export clear, echo clear, where you're clearing the screen. So setting up and using a script variable to clear the screen. If you type this in your command window, and I'll make this a little bit bigger so you can see what I'm talking about. Try that out. You'll see how it works actually in the command window. And then you go, oh, that's a lot faster. I don't really mind about waiting for my command to be found. My system's running pretty fast. But in the old days when processors weren't so fast and bandwidth wasn't so good, and we had simultaneous users on there, to run a system command actually does take longer because the system's interpreter's got to go out and find that command. So in terms of creating an algorithm to place the cursor, what's the cursor? What's that blinking light you keep looking at when you go to the terminal prompt? Well, you can move it all over the screen because, like in this particular example here where we had a menu, we placed the cursor here, and otherwise the cursor position would be over here as a normal prompt because you ran a script, and we're talking about scripting, so you run a script and you want the cursor to be up here or something maybe. Maybe you want to use it as a down arrow. It starts here and it goes down to here and then it stops and won't go any further. So seems kind of like an old style thing, but people still do this today. So in order to place the cursor, to correct data perhaps entered in from previous data entry, move cursor back to some sort of an error field, or use it for a menu selection as I just went through. So if the user enters a minus and hits enter, the cursor is repositioned at the start of the previous field. To accomplish this, the first step is to create the program algorithm. Creating the algorithm is nothing more than writing a sequence of commands or instructions that produces a desired result. So a good practice for creating an algorithm is both the logic and the design shown in a flowchart with conditions necessary to carry out the logic. So in terms of where you would do that in terms of creating an algorithm program, this would be incorrect information has been entered in by the user. You could stop, your algorithm could actually say, well, this is bad information, and you left the last name blank. So you'd move the cursor back up to the last field. This is equivalent to web forms that make things in red and say, hey, you forgot the username. or you forgot your credit card number or something. But it's placing the cursor is how we're doing it in Windows, in a Linux environment. The algorithm has encountered a minus sign and moves the cursor to the previous field to say, hey, that's not right. The minus sign is not your last name. So go back up. In fact, people use the minus sign actually to indicate a bad entry. If you put a minus sign in a web form, people will look at you funny and go, what does that mean? Really kind of an outdated, I don't know if it's outdated, but it's actually, if you saw asterisks, it's kind of interesting how users are trained just by using programmers' inventions. You saw asterisks in a field, first thing that comes to your mind would be, oh, that's a password. That's hidden. How did you know that asterisk meant hidden? You learned it. So in the old days, minus signs meant, oh, something's wrong. You have to fill that in. Now it's red. If you mark it with red and you highlight the field on a web form, people go, oh, that's where the mistake is. And you go back and you fix it. So protecting against entering in duplicate data in this particular application, and this lecture slide set is set on this telephone book application as an example. You can input validation. You could use input validation if checks for it is necessary, because users don't always enter in valid data. In fact, this is the same thing with web forms and other things. Proms should always check to ensure that the users enter acceptable information. So you can put together a little flow chart. And putting together the flow chart, you can kind of go from point A to point B and kind of see, well, what did they enter in the phone number correct? Is it on file? Yes, then it's a duplicate information. Or no, then. And you would use the same logic in programming and the same logic in scripting, actually. So protecting against entering a duplicate data, as in the example to continue it, the phone number phone add, now would have an input verification. I would see, is this phone number already in the system? If it is, it goes down here and says, well, this person's already in the system. The number's already been assigned to so-and-so. And you can kind of see this message that was printed on the bottom of the screen. The number already has been assigned to somebody, so you can't put it in. So using shell functions. A shell function is a group of commands stored together in memory and assigned a name. So it's the same kind of concept as a function in programming. Shell scripts can use function names to execute the commands. So you can actually run functions. And so what are functions? They're sort of like mini scripts. And they're defined in the shell environment, which is why you want to have access to the shell scripts and to the login scripts to the shells, because then in the login script you can define all these functions. And then in the shell you can run all the functions. And it sort of automates, it really adds a lot of power to the shell environment. So shell functions isolate reusable code sections. No need to duplicate the same algorithm throughout your program. You can call the functions from the scripts. So if you decided which shell you wanted to use, design the login to the shell to define the functions that you're going to use. Write scripts in the shell to run those functions. Make sure you're running that script in the correct shell that has the correct environment variable set and the correct function set. Run the script and voila, you've got some pretty good automation going on. In fact, you can run those same functions in any script you write in that shell. So not only are you saving time and energy, but you're creating some pretty good functionality. So defining a function from the command line. If you were to do it manually, you would enter in the function from the command line, enter in the name of the function, enter the internal block in brackets. And so the shell will have a prompt with here's a symbol here for the next line until the closing bracket. This bracket here is entered. So arguments are positional, 1 through 9, or however many arguments you have. Creating function, actually there's a cap on the number of arguments in most shells actually, which is interesting because it has something to do with capabilities of storage and memory that's allocated for the shell. In some shells you can actually allocate more memory and a higher priority for the process that's running the shell than some other shells, which is kind of interesting. There's a lot of flexibility in terms of the system configuration. So create a function inside a shell script supports code reuse. Functions can be automatically loaded and defined upon logging in. And this is where I was alluding to. By editing these two scripts, every time you went into the shell, you would set that function so it worked for you automatically. And it's kind of a short lecture, but Didn't really have too many other things to tell you outside of you know, some little tidbits that I sort of left out on the first one. So in summary, use the first line of the script to tell the operating system which shell to use with the script. It's kind of an important point to reiterate. The test command is good for validating the existence of directories and files and compares numeric with string values, also interesting and important. The sed command reads a file as its input and outputs the file's modified content. Translate changes the characters typed at the keyboard, or filters the input from the output of another program or command. Translate is used a lot with piping, as we saw. To speed the clearing of the screen, you can assign the output of the clear command to a shell variable clear, and you can automatically just write to that. Algorithms as a concept is a sequence of instructions or commands that produce the desired results. Algorithms are implemented in the form of functions, and functions are loaded in the shell environment manually, or they could be loaded into the login scripts to run automatically. Shell functions can isolate program code to be used or reused in multiple different programs. So that's everything I ever wanted to know about advanced shell scripting. It really wasn't that advanced. It's just basically a summary of some things I left out of the previous lecture that were sort of interesting to note, kind of key features. So I'm going to end this one.